Hi students, I'm going to start in this video the content for chapter 1.4 or chapter 1 subsection 4 quadratic equations. First, I would like to review a little bit of vocabulary and then recall also some properties that you need to know to be able to work with quadratic equations. The first part that I would like to go over is the vocabulary of radical expressions. This is a radical term or a radical expression, the whole thing. We call this the radical symbol, this little house with like a tail. It's called radical symbol. The value that gives you the degree, it's called index. The most popular one is the square root, which has an index too, but normally we don't write it. We just put the radical symbol by itself. So whenever you don't see a number in the index location, assume it's 2, unless it's giving you a number. And the expression inside your radical, it's called radicand. This is called radicand. Now let's move on to the properties. The first property, it has to do with multiplication, a multiplication term or a multiplying term in the radicand. When you have a number that you can factor out in your radicand, you can also factor it out into two radical terms multiplying each other. And let me go over the first one, the first example of this set of examples. Let's try to simplify the square root of 50. First, I'll need to factor out my 50. And there's different ways you can factor out 50. You can say 5 times 10 or 50 times 1. That's another option. Or 25 and 2 and so on. Normally, when we want to simplify our radicals, we're always looking for an option that will give us a perfect square. Which takes me to the next term that I need you to recall from your previous math classes. All the perfect squares are numbers that when you take the square root of them, gives you a whole number. It doesn't give you a decimal. And you don't have to memorize this because if you want to write down the list, you can just square all the values you know. For example, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So 1, it's a perfect square because the square root of 1 is 1. 4, it's a perfect square because the square root of 4 is 2. If it gives you a number after you take the square root, a whole number, no decimals, no fractions, then it's considered a perfect square. So all the circled numbers that you see here, 1, 4, 9, 16, 25, and so on, all of those are perfect squares. Going back to our simplifying radical, we had 25 times 2. So I'm going to be using 25 to factor out my 50. That way I can be simplifying. I can simplify. So the square root of 50 is the same thing as the square root of 25 and 2. And then by the property, I will rewrite it as a product of roots. The square root of 25 times the square root of 2. Remember, the square root of 25 is equal to 5. So my simplified radical, it's 5 square root of 2. For 48, I can think of using my list of perfect squares. 48 could be 16 times 3. 16 times 3. Remember, I'm choosing these numbers in particular because I want to have a number at the square root of a perfect square, so I end up simplifying my radical. The square root of 16 times the square root of 3. The square root of 16 is 4. So my answer is 4 square root of 3. And the square root of 8, going back to my list, which one of these perfect squares could be a factor of 8? I'm going to choose 4. 4 times 2. 4 times 2. After using the property, I have the square root of 4 times the square root of 2, which simplifies to 2 square root of 2. Because 4 is the square root of, the square root of 4 is 2. Because the square root of 4 is 2.